We already see how to differentiate between your axial load, eccentric axial load, transverse shear load and eccentric transverse shear load. So let us solve some of the basic questions on the how to see which type of load it is for which kind of a member, and how you can be visualize that yes, this is a eccentric transverse shear load or it is a TSL or normal load. So let us say that this is our first case. These line represents the longitudinal axis of a member, right? This is the longitudinal axis of a horizontal member. This is the longitudinal axis of this beam, and this is the longitudinal axis of this beam, right? The line represents the longitudinal axis. So if there is three beams here or three structure member are there, one is AB, one is BC and one is CD. So we have to find what is the type of load for each of the member if there is a force acting in this direction, that is P, right? So if I say that for the member CD, if I solve it one by one, for this member CD, this is the longitudinal axis. The load P is passing through the longitudinal axis, and if this is the longitudinal axis, so this will be the plane of cross section. So this P is perpendicular to the plane of cross section, passing through the longitudinal axis. So this P for the CD member is a axial load. This is a axial load for the CD member, right? If a load passing through the longitudinal axis and perpendicular to the plane of cross section, that load is your that load is your axial load. If I see for the member BC beam is like this. This is the longitudinal axis. So this load P is perpendicular to the longitudinal axis, and this load P is passing through the longitudinal axis. If you see, the line of action of force of this P is passing through the longitudinal axis and it is perpendicular to the longitudinal axis. So the load which is perpendicular to the longitudinal axis and passes through it is known as the transverse shear load. So this P for the member BC is a transverse shear load, right? If you see for the member AB, this is the AB, longitudinal axis of this member AB is this line. If this is a longitudinal axis, so this plane perpendicular to the plane of this board, this plane is the plane of cross section. So the load P is perpendicular to the plane of cross section, but do not pass through the longitudinal axis. This load P is parallel to the longitudinal axis, but do not pass through it. So this load P is a kind of eccentric axial load for the member AB, right? Eccentric axial loads are those loads which are parallel to the longitudinal axis but do not pass through it. So the load P for the member AB is a eccentric axial load, and if it is a eccentric axial load, then eccentricity will be equal to the perpendicular distance between your point or line of action of force and the longitudinal axis. So this will be the eccentricity E. So eccentricity will be equal to the length BC, right? Eccentricity will be equal to BC. So this load P is axial load for this CD member, is a transverse shear load for this BC member, and is a eccentric axial load for this AB member, right? This is how you can find that this load is of which type for which member. If we go through this second example, the same structural member is there, AB, BC and CD, but now the load is in this downward direction. If you see that in this CD case, if this is a CD and the load is in this direction, this is the longitudinal axis of the CD member. The load is perpendicular to the longitudinal axis and it is passing through it. So the load which is perpendicular to longitudinal axis and passing through the longitudinal axis is a transverse shear load. So this load P is a transverse shear load for the member CD. Right. Now for the member BC, this is the member BC, this is longitudinal axis of member BC. So this load P is parallel to the longitudinal axis, but do not pass through it. It is not passing through BC. So the load which is parallel to the longitudinal axis but do not pass through it is a eccentric axial load. And in this case the eccentricity would be the perpendicular distance between line of action of force and the longitudinal axis. So in this case eccentricity will be equal to CD. Right, eccentricity will be equal to CD. For the member AB, if I want to know that for the member AB, this is the longitudinal axis of AB, this is the load P in this direction. So the load P is perpendicular to the longitudinal axis AB and passing through it, right? So any load which is perpendicular to the longitudinal axis and passing through it is a transverse shear load. So this is a transverse shear load for the member AB, right? So this load P is a TSL for CD, eccentric axial for BC and TSL for AB. If I say, if this is another example, if this is the member ABCD, right, and the load is in this direction, in the plane perpendicular to the board, this inclined line shows that the load is in this direction, right, perpendicular to the plane of the board. So if I say that the load is like this is the longitudinal axis CD, the load is perpendicular to the longitudinal axis and passing through it. So any load which is perpendicular to the longitudinal axis and passing through it is a transverse shear load. So the load P is a transverse shear load for the member CD. So if I say, let us suppose for the member BC, this is the member BC, this is the load P in the plane perpendicular to the board. So this is the longitudinal axis, right? This is the longitudinal axis. The load is perpendicular to the longitudinal axis, but it is not passing through the longitudinal axis. The load is perpendicular to the longitudinal axis. This is the longitudinal axis in the plane of board, and this is the load, and this load is perpendicular to this BC, but it is not passing through BC, it is having some distance. So the load which is perpendicular to the longitudinal axis but do not pass through it is a eccentric transverse shear load, and the eccentricity will be your perpendicular distance between line of action of force and the longitudinal axis. So the eccentricity will be equal to CD, right? Now for AB we can say this is the load, right? This is the longitudinal axis. So the load is perpendicular to the longitudinal axis, but it is not again passing through the longitudinal axis. So the load which is perpendicular to longitudinal axis but do not pass through is a eccentric transverse shear load, and in this case the eccentricity will be the perpendicular distance between line of action of force and the longitudinal axis. This is the eccentricity. So in this case your eccentricity will be equal to BC, right? The eccentricity will be equal to BC. This is how you can identify any load with respect to the longitudinal axis, and by seeing the nature of the load with respect to the longitudinal axis or the plane of cross section, you can identify whether it is a normal load or shear load, and in normal load whether it is a axial or eccentric axial, in shear whether it is a transverse shear or eccentric transverse shear, right? So let us solve one numerical on your impact factor or impact loading. The numerical says that there is a block which is having a weight of 5 Newton drops inside a cylinder from a height of 200 mm, right, onto a spring having a stiffness of 90 Newton per meter. We have to determine what is the maximum deflection of spring and your impact factor. What is the impact factor and what is the maximum deflection of the spring? So if I draw the diagram, this is the cylinder. There is a spring attached here whose spring constant will be given 90 Newton per meter. There is a weight of 5 Newton which is at a height of 200 mm, and this is dropped from this height. So when the weight touches or strikes the spring, it exerts a impact load on it. So because of that impact load, we have to find what is the deflection and what is the impact factor. We already see the process or the procedures to follow when you are solving the impact loading numericals. We say that assume that the impact loading will be a static loading. So I can say assume it to be a static load, means this 5 Newton will act on this spring in static condition. There is no impact loading. So if this 5 Newton will be applied on this spring statically, we can say the delta static or the static deflection will be equal to weight upon spring factor, right? Because in spring we know that force exerted on the spring or exerted by the spring will be equal to its spring factor into the deflection. X is the deflection of the spring. Compression or elongation, X is the deflection of the spring. So the static deflection of the spring will be equal to the weight divided by the spring factor. Weight is 5 Newton, spring factor is 90 Newton per meter. If I want the deflection in mm, so I multiply it with 1000. So the static deflection will be 55.56 mm. This is the deflection when we considered it as a static load. But actually this is your impact load when this block strikes this spring. So we know the impact factor. Impact factor will be equal to 1 plus under root 1 plus 2h upon delta static. So if I put the formula, height is 200 mm, delta static is this 55.56. So if I solve for it, then the impact factor will be your 3.86. After solving this, you will get the impact factor will be equal to 3.86, and we know that any parameter, if we have to find any parameter for the impact loading, that would be equal to that parameter under static loading into impact factor, because we see that sigma impact will be equal to sigma static into impact factor, and delta impact will be equal to delta static into impact factor, right? Any parameter if you want to calculate for the impact loading, assume it as a static loading, so that static parameter into impact factor. So we have to find what is the impact deflection when this weight or this block is applied a impact loading on it. Then the delta impact will be equal to your delta static when you assume it as a static loading into impact factor. So if you multiply this static loading into impact factor, you will get the delta impact will be 214.66 mm. So the maximum deflection of the spring will be your 214.66 mm. So this is how you can solve the numerical for the impact loading.